Welcome everyone to the third video in a series of videos on solar and wind energy estimation and forecasting application developed in MATLAB. I'm Kiran Gaikwad, the developer of the application. I have a Masters of Technology in Power Electronics and Power Systems from Sardar Patel College of Engineering, Mumbai. I'm currently working as a Junior Project Fellow at GERMI, Gujarat Energy Research and Management Institute, under Dr. Sardar Agrawal. In this video, we will have a demo on the solar energy estimation application. As we know, the energy estimation application is a sub-module of the solar photovoltaic energy estimation application, and this is the main interface of the solar photovoltaic energy estimation application, and we are interested in the main application, that is the grid connected PV or energy estimation application. So to cut down on time, I have already opened the grid connected PV energy estimation application and populated it with some inputs. So as we can see, the first step is to input the site data, which is the project name, here a random solar power plant capacity in kilowatts. So I have taken 5000 kilowatts, latitude and longitude of the plant location, and over here I have kept the plant inside Gujarat at latitude of 23 and longitude of 72 degrees. And then the second step is to input the PV module data. So the values required are the module power in watts, that is 145, the total number of modules, the PV technology, it may be crystalline or thin film. So now this module is a thin film one, so I have put in 2. The module temperature coefficient in percentage per degree, the STC temperature in degrees Celsius, and the STC insolation in watts per meter square, that is 1025. The third step is to determine the orientation of this plant. So in this application we have provisions for using these 5 types of orientations: fixed tilt, seasonal tilt, single axis east-west tracker, single axis north-south tracker, and double axis tracker. For the purpose of this demonstration, we will use single axis east-west tracker, and we can select this radio button and click on this button. And we have this window to pop up where we can enter the maximum assignment and the minimum assignment and tilt of the module for the single axis east-west tracker system, and we can say OK. We should not close this window until the simulation is done, so we can just minimize it. The fourth part of the simulation is the period of simulation. So we are using the year as 2012, which is a leap year. We can enter the starting month, the start day of that month, the end month, the end day of that month to determine the simulation period. The fifth step is computation options and weather data. So now over here we will enter the simulation resolution, that is 15 minutes. That we will compute every value at an interval of 15 minutes. And the most important part of this application is the mode of computation. So there are 3 modes available to us for computations. The first one is use of irradiance calculator, that is based upon clear sky model. Then the second one is that when user has an irradiance file, a sub-hourly resolution irradiance file to be precise. And the third one is when the user has a daily insolation file rather than a sub-hourly irradiance file. So first we will look at the mode 1, that is using an irradiance calculator, and for this we have to input some more information. This is the rainy months information. So we can select the type of clear sky model. So there is the normal model, the usual one, and then there is this modified model which I have modified using some data analysis for Gujarat, and we will go to it in a while, but in this particular demo let's stick to the normal clear sky model. We will select normal and we can press OK. Even this window should not be closed into simulation, so we can minimize it. Then the third step is to load weather files, and now I have weather files for this location in an RD format, so I will not use this resolution wise format, but I will click on this radio button that implies it is an RD file, and then to load the temperature file I click on this, maneuver myself to the location of the file, to take some time. It's over here somewhere. Yes, and this is the leak file for this one. Temperature. Okay. The second file we require is the wind speed file, that too in early resolution. Click on wind speed. Reach down over here. Okay. And the wind speed for a leap year for this time early. Yes. Now we have loaded the weather files now, and then the sixth step in performing the simulation is the loss parameters. Click on that. So we have this loss parameters window which has some fields to it, and there is the selection of those radio buttons. Now it is at default values, so if you want to change these default values, you can click on user defined radio button and we can ready to change the values, but maybe for this demonstration we will keep them to default values, and we press OK. And the final step is to click start simulation. We wait for a while for the files to generate and outputs to come. It will take some time. I think I'll pause the video over here. Now let it be. We will wait for the simulation to complete. It's taking unusually longer time. Okay, something is happening. I think it's working. So, okay, we have the final report GUI. This is the final report GUI, and this is how we are having our output. And this is the monthly. We have like the outputs are shown in the table format over here, and in graphical format for a particular variable in the table. And here is this is the monthly axis, and this is the actual variable value axis, and over here we have the table. So what we compute during the simulations are the variables like PV output in kilowatt hour, inverter input, inverter output, energy to grid, error mismatch loss, LID, shading loss, ohmic loss, inverter loss, tracker loss. We haven't specified any tracking loss element into the loss parameters window, so we have all zeros over here, and the transformer loss, which all are given in kilowatt hour, and they are all divided into monthly resolution over here. So, and this one shows the month-wise energy output from a PV array, that is this one. And if we want to see the next thing, we will click on next button, and we have the inverter, the input to the inverters. We click again next, and we have month-wise energy output from inverters. We click next, and we have month-wise energy output to the grid. So this is what we are interested in. Okay, and then over here we have the project details as we input it to the application. Then there is total energy at different points, that is the PV module output, inverter input energy, inverter output energy, energy to grid, and this is all the sum of all the months together over here in kilowatt hours. And then there are total losses in an entire year, because our simulation period was for an entire year of 2012 from 1st January till 31st December. So these are all the losses which are aggregated for a year, and these two are also in kilowatt hours. So this is how the window looks for the output, and this is not just it, because we can close this window now and we will go into MATLAB, and these files over here have been generated now, which are in Excel, which will give us all the values which are computed in an intraday, monthly, and daily format, and also the plant performance analysis in an Excel file. Okay, so let us close these windows over here, and let us go for rainy winter months. We can do now the modified version. So this has to be done when the user has a little bit more information about the rainfall in the area, so that our estimations or the energy estimation can be more accurate, and what kind of data he has. Maybe I have a yearly data for 2012, and we can say that area has 1000 millimeters of rainfall that year, and which months it will have rainfall. So usually in India we have a monsoon seasons from June to September, and we can select those months over here, and we can just say okay. Now we are ready to press OK, and we'll be using the modified clear sky model now. Okay, and then we have this. We keep the orientation as the single axis east-west tracker, and we have 45 as maximum azimuth, minus 45 as minimum azimuth, and tilt as 0, and we press OK. Everything else remains the same. And okay, we have the temperature and wind speed files which were loaded earlier, so we don't have to load them again. Then this is the loss parameters, and we will keep them as default values as in the previous case. Press OK, and we'll click start simulation now and wait. It takes some time. What we have to observe over here is that after giving the rainfall information, how does our energy plot look like? Usually in India, during the monsoons, due to cloudy conditions, the energy output from the solar power plants is low. So we have to observe that difference in energy in the months of June, July, August, September, which are the usual months of monsoon in India. With this computing right now. Some more time. We're on our way. Okay. Here it is. Here it is. We have this low patch over here from June, July, August, September. This is the modified effect of the modified clear sky model which we are getting. Otherwise, the last time we had something like this, it was not showing up. The clear sky model was not trained enough, or it is not accurate enough for the monsoon conditions in India. So now we have trained it, or we have modified it to incorporate the rainfall information and then utilize it for estimation, and you can clearly see that there is a dip over here, and the rest of it all remains the same. And we can close this window right now, and we will again have those 4 files which are now, we didn't delete those files last time, so they have been overwritten from the data we simulated right now. So we will just delete them right now. We have one more simulation to go, and okay, we will close all these windows again, And let's go to the main window, and over here we'll have again the east-west tracking system, and tilt of the model is 0. Press OK. And now over here what we do is that I actually don't have an irradiance file available right now, so we can't do this second mode. What we will do is when a third mode, that is the user has daily installation file. Okay, and that has to be distributed because we want our simulation resolution to be 15 minutes, and we have to distribute that daily installation file into an irradiance file, and the type of distribution should be Gaussian, and these are actually sinusoidal and average of Gaussian and sinusoidal, but the Gaussian works better than these two. Okay, so we select the Gaussian insolation distribution type, and we have our temperature and wind speed files which are in hourly resolutions preloaded, but we have to give the simulation the file, the daily insolation file. So we'll click the insolation and irradiance file button, and we'll go to the location where we have that insolation file stored. Somewhere it's here. Okay, so we have 2012 daily insolation file over here in watt per meter square. Okay, let's say open, and now we have our daily insolation file loaded up. So the sixth step would be the loss parameters, which we will keep on the default values, and we press OK. Repeat. Yes, we can now start the simulation. Now it will simulate on the basis of the insolation file we have given in, so we have a more accurate picture of the energy estimation. It will take some time. Here you can see the first Excel file, the second Excel file been created, so it has done with its computations, and it's creating those Excel files. Over here you can see that happening. It's the third file, and then it will be the last file, and then we get the final report GUI popped up on the screen. Okay, that's done. We wait for some time, and okay. It will run. And here it is. This is how it looks. And if you remember from the past slide, this is how the shape was for the modified clear sky model, which used nothing but just a random yearly rainfall value in millimeters, and we got some shape like that. Of course, the values won't be matching to that level because we didn't input a more accurate figure of the rainfall, but it was quite something like this. And over here we have the same stuff going on as in the previous two cases. So that's it. We have completed our tour of this application right now, and we saw that how to use the two major modes of operation, and we can now reset this application if we want. So it's cleared off of everything, and I can say close to this. Okay, we can close this too like this, and yes. So hence this application is useful for estimating energy from a grid connected solar PV power plant. It has three modes of computation, which are using clear sky model, both the normal one and the modified one, using the irradiance files if the user has them, or using the daily insolation files if the user has them. But in all the three cases we require the temperature and wind speed files which should be either in hourly resolution or in a resolution matching the simulation resolution. Moreover, all the outputs of simulation are stored into Excel files which have energy computations at every level in sub-hourly, daily, and monthly resolutions, and also the plant performance analysis is recorded in an Excel file. Thank you.